Hello everyone, welcome to the session where we discuss how to set up a Simulink model to represent the feedback control system based on the transfer functions. So what we are seeing on the screen is a block diagram, and this is the block diagram that we have encountered a few times in the module already. So what we have here is we have a process GP of S. That's a process that we are trying to control. So this process has an input U of S and it has output Y of S, but obviously the output Y of S is also affected not just by the process but also by the disturbance. So GD of S, GD hat of S is a disturbance model, and D of S is the actual disturbance signal that comes into this process. And as we understand, for a feedback control system, you measure Y of S, so therefore you link this Y of S, that is the real process output, through a measurement device, GM of S, that's your usual sensor like a thermocouple or level indicator, etc., etc. You get your measured Ym of S, you get your measured output, you compare your Ym of S with your set point YSP, you generate the error, and it is this error, yield of S, that determines how you control your process. So you pass this yield of S through your controller GC of S, and you get your control signal C of S. That gets into your final control element, or sometimes you call it actuator, and that becomes the input to your process, and therefore you complete the feedback loop. So what we are seeing on the screen is a number of elements for all these transfer functions. We have GP, we have GD hat, we have GF and GM. They are the same transfer function, and we have also given a control transfer function, the controller transfer function. So your task is to create a Simulink model based on this block diagram, and afterwards you can use Simulink to investigate how the process output Y, this Y of S, responds to a unit step change at the disturbance, unit step change at the set point, and a combination of those two. What I'm going to do is to demonstrate the first part of this task, to create a Simulink model based on the given block diagram, and I'm pretty sure you will be able to do the rest of these investigations. Right, so I'm going to switch to Matlab window because at the end of the day we're going to do this in Matlab Simulink. So I bring up my Matlab, and obviously you need to open up the Simulink. There are different ways you can click one of those items to find out where Simulink is, but what I'm going to do is to simply type Simulink in my command window, enter, and that brings up my Simulink start page. So on the Simulink start page, there are lots of different scenes under different tabs, but all we have to do here is really to create a new model, a blank model. That is what is called here. So I click this blank model, Simulink will open up a new window. is in the process of creating a blank model. It takes a bit of time, depends on how fast your computer is. Right, here we go. So I'm going to drag this blank model here. Right. So there is nothing, in the Simulink model. And what you would like to do is you want to click the library browser to find out all these blocks, the blocks for the transfer functions. So if you click that, you will get a Simulink library browser, and what we are looking for is a transfer function. There are a lot of different options for fairly advanced use of Simulink, but what we focus on here is a simple model. If you go to continuous is where you find all the transfer function models. Right? So you can take a quick look at different options. You have derivative, descriptor, state space. You may not understand all of them for the time being, but what we are looking for is this transfer function. Right? So we can click that, hold it, and drag it across onto your main model. So here we go. I release my mouse, I get a transfer function. Okay, so I'm going to make it bigger. I hope I can make it larger, easier to see. And if you double click it, you can set up the transfer function based on different numerator coefficients and denominator coefficients. So I'm going to go back to my brief to see what transfer functions we are trying to build. So we have GP of S. We start from GP of S is 2 over 10s plus 1. Remember that? So we go back. We are going to put a numerator value of 2, and the denominator, remember, is 10s plus 1, so it's 10, which is a coefficient for the first item, and 10s plus 1, so the second coefficient is 1. So you don't put s into the denominator window here, because all is required are the coefficients. So we click OK, we get our process model. And if you want, you can modify the name of it. If you double click, you can put a name, you can call it process. Okay. And that becomes your process model. Alright? So what you need to do next is to create several other blocks to represent the final control element, the controller, and the measurement, and all these different links. So let's try to do that. You could go back to the library browser and drag across other transfer functions. But what I'm going to do is I'm going to select this transfer function block, copy, or you can press Ctrl+C, and I'm going to paste it. Okay, so I'm just being lazy here, right? So I've got another transfer function. I'm going to put this as my. I'm going to change the name. This is GF of S. Doesn't matter, GF, that's your final control element. And then for this one, I'm going to change it to GP, your process. So let me go back to my brief to see what this GF is. So brief says GF is 1 over S plus 1. Okay, so I'm going to modify my Simulink model. Double click, so it's 1 over S plus 1, so it's 1 and 1, the two coefficients in the denominator, right, and that's it. And I can connect them. You know, what you can do is you can select the first block and press down your control button on your computer, and then select the second block. Then you create a link, a connection between those two blocks. Alright, so the rest is fairly similar. What we're gonna need is the controller, right? Copy and paste. I'm going to change this into my controller. And what else do I need? I need a disturbance. Paste. So I need a disturbance here coming from the top. And I also need a copy. I also need a measurement, which is below the whole block. Right. So I'm going to move the whole thing to the right a little bit. Just easier to see. Right. So this measurement, if I'm not wrong, we can go back to the brief. It has the same transfer function of 1 over S plus 1, so I'm not going to change that. And if you look at your GC, your controller is 0.1 over S, and your GD of S is 1 over 5 S plus 1. So I'm going to put those numbers in. Your controller, sorry, what was it? It was 0.1 over S. So it's 0.1 over S. You still need the 1 here to represent this is the coefficient for S, and you need a 0 here to represent you don't have a constant. So that's that. And your disturbance, I'm going to put GD, disturbance, if I'm not wrong, it's 1 over 5S plus 1, right? And I'm going to connect the controller to the final control element. Okay. And what else do I need to do? I need to change the direction of this measurement, because at the end of the day, when you measure output, it goes back. It's a feedback loop. Right. So if I click the block properties, I'm pretty sure there is a way that we can reverse the direction. So double click that. You click this block, right hand side, click, you find the rotate and flip. You could actually flip the block to change the direction of it. Okay, here we go. So what else do we need? We have all these blocks pretty much. And if we go back to our block diagram, we need a couple of links. So here is a link where you add those two together. You add the output, you add the process output and the disturbance to become the actual output. And you have this feedback, which is plus minus operations to compare your set point and your measurement. Okay. So those are the two links, if you like, that we need. And in the same time, we also need to represent this D of S and the YSP of S. D and Y SP, those are what comes into the entire block diagram. You can come up with anything for the D and YSP. They can be any signals that comes into your process. But what we normally do is we use step changes, right? So imagine if you have a step change at your YSP relating that to the physical system, what that actually means is you change your set point from one value to another, right? Whereas when you have a step change in your disturbance, you are essentially saying my disturbance suddenly changes from one value to another, and you want to observe how your process, how your control system responds to that. So I hope that makes sense, and therefore I'm going to use a step change for your disturbance and step change for your set point as well. So I'm going back to my Simulink window, and I go back to my Simulink library browser. So for this kind of step functions, what you can find is under the tab Sources. So sources, as we can see, there are a lot of different signals you can put into your system. We scroll down, we find the step, that's what we need, and we click and drag it out, so that will be the step we need. I'm going to give it a name here, so it's your disturbance, and I will connect this disturbance to the disturbance model, right? And if you double click that, you can see there are a number of parameters you can change for this step change. Step time means where your step happens, when your step happens, and the initial value and final value means at the step time your step change goes from your initial value, here is 0, to your final value, here is 1. Right, so those are the three things you can modify primarily. And if you don't want your step time to happen at the very beginning, you can change this value. If you want a step change that has a magnitude of not 1 but 10, you can put a value of 10 here, saying you have a step change going from 0 to 10. Okay, so that's fairly straightforward. I'm going to go back to 1 and I click OK. That's my disturbance. I copy that, paste that into my set point YSP. So as we agreed, we are going to have a step function at the disturbance and set point to represent those two signals. And what do we need next? Well, finally, we need the sum and the subtraction operations to put the whole thing together. So you should be able to find those again under one of those tags. I think it is under the math operations. Okay, so there is one item says add, so I'm going to use this one and drag it across. Okay, so I'm going to add from the disturbance and the process. That becomes your output, right? So I'm going to link this output to your measurement device. We measure it, and I will click that, I copy it because I need another one. For the set point and the measurement. But here is the difference. If we go back to the block diagram, you will see here is plus plus. You sum those two branches together. Here is plus minus. This is plus, this is minus. It means you have a negative sign coming from your measurement, which makes a lot of sense because you are calculating the error. You are calculating the difference between set point and the measurement. So we need to modify this block. You will see the list of signs is plus plus. By default, I'm going to modify that into plus minus. Click OK. So you will see one of the branches becomes a minus. Let me make it slightly bigger. Right. So you link your measurement. What I'm doing now is I use my right mouse click to link this line to the minus, and then I can link the set point to the plus, and finally I link this difference into my controller. Right. So if you compare this with the block diagram we have on the brief document, it's more or less done, except normally in the end we want to be able to see what happens at this output. Right? You should be able to visualize the output. So the way we do that is we put another display, like we're trying to link this output to a display. So therefore we will be able to see it. That can be found under one of the blocks. I think it's sinks. There are a number of things you can use. We normally choose scope. Okay, so it's not obvious what's the difference between a display and a scope. We're going to explain that later on. But if you click the scope, drag it on, right? And if you click this point, use your right mouse, right click, hold it, and link your output Y to the scope. I'm going to name this scope my output value Y. Hope I can do that. Y. Okay, here we go. Right, that completes more or less the block diagram setting up in the Simulink. Now what you can do is you can actually run the simulation. There's one more thing you need to be careful. The stop time means for how long your simulation is going to run. Say for example, you can run for 10, whatever time units you used to build your transfer function models, or you can run it for 100. You click run, the simulation is running, and initially it takes a bit of time, but it should be fairly quick. Now it's done. If you double click your scope, you will see a plot of your Y. So this is the plot that we simulate for your output Y. And I'm going to pose this as a question to you guys. Why the output Y behaves like this? Why it goes from 0 to a larger value, oscillates a bit, up and down, and apparently it seems to be converging or settling at the value of 1. Why is that? Does that make any sense? Okay, so that's the food for thought. And after you are familiar with setting up the Simulink model by yourself, then you can move on into the other part of the questions in the brief document. Hope you enjoy it.